Okay, new circuit. And search the diode. This diode, 4 diodes, 1, 2, 3, and 4. Okay, and move the ground just here. This diode, this rotate just like this, and move this another diode here, and this rotate. Very nice. Okay, you can drag the workspace to move. Okay, join these nodes. This node, click with this another node, and this with this. Very good. The resistor, click on resistor, place it here. Okay, the ground. Another ground, click on ground and place it here. Okay, join this ground with this node, click here. Very good. And this node with the resistor. Very nice. And the alternating current source, click here, AC. Okay, and join this node with this another node, and this node with this another node. So click on alternating current source, adjust, and I will use a DC voltage of 0, amplitude change to 5 volts, amplitude to 5 volts, frequency only 60 hertz, phase 0. Okay, very good. And click on workspace and drag. Okay, click here on this node and show waveform. I will show the waveform on this node. Okay, in blue, and click here on this node on resistor. Resistor is the load. Okay, and show waveform on green. Very good. This configuration is the diode bridge. Okay, diode bridge for rectification. And you will see the difference. Okay, and run transient. Very nice. But click here on simulation speed and change the simulation speed to 10 milliseconds per second. Okay, remember that the real time is 1000 milliseconds per second. I'm using simulation speed of 10 milliseconds per second. And now, look at the value of the resistor is 1 kilo ohm. Okay, and on green, the waveform, the rectified waveform. And on blue, the alternating current source. Okay, and now you can see the alternating current source in blue, maximum value 4.24 volts. The minimum about 0. Frequency 60 Hz. The rectified wave on green, maximum value 3.49 volts, and the frequency is twice 120 Hz. And you will see the waveforms. The frequency of the waveform on green is the double of the waveform on blue. Okay. Okay, and remember the waveform on green is the full wave rectification. And very nice, but why the maximum value of the waveform on green is 3.49? Okay, and click here on alternating current source, and remember the amplitude is 5 volts. 5 volts. Okay, click on workspace. You have 5 volts. And remember, what is the voltage, the operation voltage of the diode is about 0.7 volts. So minus 0.7 equal 4.3. But remember, you will use two diodes. You will use two diodes for the full wave rectification. So again, minus 0.7 equal 3.6. So that's why the peak or maximum value of the rectified waveform is 3.49 volts. Okay, very close to this theoretical value. Okay, and also you can add a capacitor, polarized capacitor, or this capacitor. I will use polarized capacitor. Okay, click here. Very good, and place it here. A ground, and By default, the value of the capacitor is capacitance 1 microfarad. Okay, 1 microfarad. By default, and join this point with this another point with the resistor. Okay, resistor and capacitor in parallel configuration and run transient. And you will see this is a little different. Okay, focus on the green waveform, the full wave rectification. Look at the peak or the maximum value of the green waveform is 3.49. The same before to place the capacitor. Look at the minimum value of the green waveform is 172 millivolts. 172 millivolts. Okay, I will pause the simulation, pause, and I will remove the capacitor, okay? Remember this number, maximum value 3.49 and minimum value 172 millivolts. And remove the capacitor, select the capacitor and delete. Okay, and run transient. Okay, and look at this. Maximum value of the green waveform 3.49, the same, but the minimum value is about zero. About zero. So if you use the capacitor, the minimum value of the green waveform will increase. Okay? Stop, pause simulation and click on polarized capacitor. Place it again. Join the nodes. Resistor with capacitor, parallel configuration, and run transient. Wait a minute, and now you will see minimum value is not zero. Minimum value is 172 millivolts. Click on capacitor and increase the value of the capacitor. Adjust. I'm using 1 microfarad. I will use 10 microfarads, and look at the difference. Very good, my friends. The maximum value is still 3.48 volts or 3.49 volts. Don't worry about this. It's the same before to place the capacitor. But the minimum value of the green waveform is 2 volts now. So if you increase the value of the capacitor, the minimum value of the green waveform will increase. Will increase too. Okay? Okay, this is very good, and you can allow the difference between maximum value and minimum value of the green waveform. Okay, 3.48 volts minus 2 volts equal 1.48 volts. This is called the ripple voltage. Okay? The difference between the maximum value of the green waveform and the minimum value of the green waveform is the ripple voltage. But also increase this to 100 microfarads, and the waveform looks like a DC voltage, almost like a DC voltage, and calculate the ripple voltage maximum value 3.4 minus 3.19 3.19. The ripple voltage now is 0.21 volts. Okay, using a capacitor of 100 microfarads. Okay, and change this to 1000 microfarads or 1 millifarad, and you will see this new voltage that looks like a DC voltage. Okay, maximum value 3.33 and minimum value 3.31. Maximum value 3.33 minus 3.31. So the ripple voltage is 0.02 volts or 20 millivolts. Okay. Finally, this is how you can convert or adapt the alternating current to direct current, AC to DC. Okay, convert alternating current to direct current. You can see the input, the alternating current on blue, and the output, the direct current on green. Thank you very much, my friends.